Hey guys, good morning. I wanted to talk to you a little bit about energy. This is the energy unit, and we've actually started with work. I've had you doing a couple of examples with some graphs that involve work, but work is really just going to be the change in the amount of energy that an object has as we learn longer. So, talking about what the heck is energy? Well, when we're dealing with energy in the real world, we talk about all kinds, but like we might deal with energy specific from the sun. And the sun has this crazy amount of energy that it provides to the earth. We wouldn't be able to do much without that. It provides thermal energy to keep us warm. It sends light down, which our plants use photosynthesis and kind of turn that energy into other things that help us out. But we do get certain types of energy from the sun. Those aren't the types of energies that we're talking about in this unit. But keep in mind that the sun has a lot of energy. Right? We also talk about the energy that we see in our household appliances. We'll learn more about something called power, how much power it takes to run this. But at any given time, we're talking about the amount of energy that, electrical energy, that makes this thing run. Okay? Well, we're going to be talking less about thermal energy and electrical energy because those are kind of physics 2 topics, and more about mechanical energy, which is broken into like two and a half pieces. We'd be talking about kinetic energy, potential energy, and there's another type of kinetic energy that we'll talk about later. But kinetic energy, okay, so I've got here 3 objects from Super Mario. Okay, we've got the Bullet Bill. If you wanted to go look this up, Bullet Bill was introduced in Super Mario World. So you could just type in like Google Super Mario World Bullet Bill and see what it looks like. Koopa shells and piranha plants have been in the Super Mario World since the beginning. That was confusing by calling it Super Mario World. They've been in Super Mario since the beginning of the franchise. Koopa shells are just launched really, really fast. Piranha plants just kind of chill. They don't do much, kind of hanging out in one place. And what I'm going to ask you to do is, if you're Super Mario and you're just kind of like hiding down here, you've crouched, you're protecting yourself. I want you to pause and think about how much each of these things would hurt if they ran into you. Okay, so here you are, minding your own business. In these 3 situations, what's going to cause the most pain to you? Okay, so you've got your pain. Thank you for taking that pause and thinking about it. If it were me, I'm going to go ahead and say that this object, if I'm chilling and this object doesn't go anywhere, there's literally no way that it can hurt us. So I'm going to go ahead and say, yes, it's spiky, but if I'm over here and it's over here, it's not moving, it can't get to me. This one really can't create energy. Sorry, this one can't create pain. It doesn't really have energy because it's not moving, or at least kinetic energy that we talked about. This comes in a little bit more, and I would argue that the Bullet Bill is going to hurt more than the Koopa shell. Okay, so my order would be Bullet Bill would be the most pain, Koopa shell next, piranha plant last. Okay, now I want you to pause one more time and think about when you were looking at pain, what about these things made you consider whether it would hurt more? Okay, were you talking about the color of it? Probably not. But what quantities, what specific attributes of the objects contributed to you thinking about its pain? Okay, thank you for taking that pause. I'm hoping that you recognize that since this object was not moving and therefore couldn't really hurt us, that the velocity must have had something to do with the amount of energy or the amount of pain that it can cause. Right? On the flip side, if both of these are going that same speed, why is it that the Bullet Bill would hurt more? Well, I'm assuming you can recognize that it's based on mass. Okay? So what I'm going to have you do is look at some examples and just kind of rank them again, thinking on your own, keeping in mind mass and velocity.